All right, today we're going to be working with division. That is the last of our operations that we've not covered, okay? Division is going to work a lot like multiplication, okay? Because when dividing the radicals, they must have the same index. So that is our first blank. They must have the same index in order to divide them. When dividing exponents, anybody know what we do with the powers? Subtract them, right? When we multiply, we add them, so it makes sense that when we divide, we would subtract. You can never leave a radical on the bottom of a fraction. We'll talk about what that means here in a second. Okay, so we've got a couple examples here. It just wants us to simplify them and to not leave a radical in our denominator. Okay, so the way these are written is not with a math type, but that's okay. So what this is basically saying is cubed root of 32 divided by cubed root of -4. Okay? So what we're going to do, first off, check our indexes. Are they the same? Yes, so we're good on that. And now we can just divide, okay? Basically what we have are just the coefficient 1 out here. Well, 1 divided by 1 is just 1, and I don't really need to write that, so I'm not going to worry about that part. But what's 32 divided by -4? -8. So this just becomes cubed root of -8. Can I solve that? Yeah, for sure. 8 breaks down to -4 and 2, or -2 and 4, or I could just go ahead and pull that negative out, but either way. This will break down to 2 and -2, and my answer ends up just being -2. Good. Next one, square root of 243 over square root of 27. Are those like indexes? Like radicals? Yes, they are. 243 divided by 27. Use a calculator. What do you get? 9? Square root of 9?
Yeah.
Will that simplify?
Yes.
To what?
3.
3. Okay. Now we're going to toss in some powers here. Get excited. Cubed root of 162x to the 5th over cubed root of 3x squared. Same index, right? So we're good on that front. Let's start with just the numbers. So 162 divided by 3. 54. And then x to the 5th divided by x squared. X to the 3rd. We subtract those powers. Subtract the powers. 5 minus 2 is 3. Okay. Now we'll see if we can simplify this a little bit further. So 54 can break down to 2 and 27 is what I heard first. 27 breaks down to 9 and 3. 9 breaks down to 3 and 3. Any groups of 3? 1, and it is 3. I have 3 x's. How many groups would that be? Just 1. And then what's left over? Just the 2. Cubed root of 2. Good deal. Okay. Next up, we have handling our negative exponents. So we have a negative exponent rule, and we should know this already. But moving a power across the fraction bar, so from numerator to denominator or from denominator to numerator, changes its sign. So moving a power across the fraction bar just changes its sign. So for instance, if I had 1 over x to the -4th, I can just move that up and it becomes a positive x to the 4th. Okay? If I had x to the -7th, how could I rewrite that? Yep, 1 over x to the 7th. if I had, we'll do one more example here, y to the negative 2 times z to the 4th. Well, the z's are already positive, so I wouldn't want to move that, right? But I could keep that on top and move the y down to make it positive. Have we seen this before? Yes? Cool. Okay. We will go ahead and get moving on these. So the first one is just cubed root of 56a over the cubed root of 7a to the 4th. So the first thing I want to do, don't have any coefficients, so I don't have to worry about 1 over 1. My indexes are the same, so I'm good on that. So the first thing I need to do is just 56 divided by 7. What's that going to be? 8. So keep my same radical, and I've got an 8 up top. And then I've got a to the 1st over a to the 4th. A to the negative 3rd. So 1 minus 4 is negative 3. Okay, so here's how this negative exponent rule is going to work. The 8 is to the positive first exponent, so I'm going to leave that up top. I don't need to move that. However, I can move the cubed root of a to the negative 3rd to the bottom, and it becomes positive. So a to the 3rd. And now I can just break these down. The cubed root of 8 breaks down to 2. Okay, you could go ahead and factor tree that out. You might know that one by heart by now. It's just one group of 3 2s, so it's just 2. And then I have 3 a's in the bottom, which is just one group of a's. 2 over a is your answer. Questions on that? Okay. Okay, we're going to go ahead and skip example 2 for now, just for time's sake. We're going to move down to example 3. Okay, so here we've got square root of 75x over the square root of 108x to the 5th. First thing I should do, so I could do 75 divided by 108, right? But I'm probably not going to get a whole number because 75 is smaller than 108, right? But I could simplify that just like a fraction. So 2 numbers that go into 75 and 108, that'll simplify that. So basically all that is a fraction that I'm simplifying. 75 over 108. What are 2 numbers that will go in? 5. 5 and 15. Will 15 go into 108? No. What's 75 divided by 9? A decimal. Okay. 3. What's 75 divided by 3? 25. So I'm going to keep this as 25. What's 108 divided by 3? 36. X to the 1st over x to the 5th. X to the negative 4th. So should I put that up here? No, I should put it on the bottom to make it positive, right? So I'll rewrite that on the bottom. And now I'm just going to simplify these roots. So square root of 25 breaks down to 5 and 5, which just becomes 5. 36 breaks down to 6 and 6. If we know this one by heart, it's going to end up just being the square root of 6, but we'll go ahead and break it down further. 1 group of 2, 1 group of 3, 2 times 3 is 6. How many groups of 2 is x to the 4th? 2. And that is my final answer. Okay? Questions on that one? Yes?
What happened to the x on top?
We subtracted them. So we did x to the 1st minus x to the 5th and got x to the negative 4th, but then we wrote it in the bottom to keep it positive. Good question. Yep. Any other questions on that? Okay. We're going to do plenty of examples today. But let's keep moving forward. So when a value doesn't go in evenly. When a value doesn't go in evenly. So here we have We've had a lot of pretty ones, right, that have worked out, okay? And now, whenever it doesn't go in evenly, we have to do what is called simplifying, which we just learned. We must simplify the denominator, okay, by multiplying the top and the bottom by the radical. So when a value doesn't go in evenly, we must multiply the bottom and the top by the radical. So this is when we are left with a radical in the denominator, okay, which we cannot have. So we're going to learn how to get rid of that right here. So this is basically just, or it is just square root of 7 divided by square root of 5. Will 7 over 5 simplify? No, there's not two numbers that will go into both of those. So we can't simplify 7 over 5. However, we know we cannot leave a radical in the denominator. Okay? So to get rid of our radical, we're just going to multiply by it. So our radical on the bottom is square root of 5. So I'm going to multiply both the top and the bottom by the square root of 5. When I do that, square root of 7 times square root of 5, square root of 35, and then the square root of 5 times the square root of 5, square root of 25. Okay, now we'll just try to break these down. 35 would break down to 7 and 5, but those two numbers will not break down further, so you'll find that square root of 35 is as simple as that one's going to go. Okay, but 25 breaks down to 5 and 5, so this just ends up being square root of 35 over 5. What I need you to put on these side notes. Okay, and we'll just do an example here. Did you notice how the square root of 5 times the square root of 5 just became 5?
Yeah.
Yeah? What you're going to find out is that square roots cancel out when you have the same radical. Okay? So the same thing, if I had square root of 25x times the square root of 25x, the answer would just be 25x. The square root of 78 times the square root of 78 would be 78. Okay? If the number underneath is the same, those symbols just cancel out. Okay? And that's that's the whole reason why we multiply by that denominator, is because we're getting rid of that symbol. Okay? So that is what we're going to be doing today, or for the rest of. So make sure you do not leave a radical in your denominator. So this one, example 2, is just square root of 2x cubed over square root of 10xy. Will 2 over 10 simplify? Yes. To what? 1 over 5, right? They both have a 2 in common. So 1 over 5. And then x cubed over x is just x squared, and I'd leave that up top, right? Because it's positive already. And then we have no y's on the top, but we do have a y on the bottom. Just leave the y on the bottom. Good. Okay. Now here is what we've got. We could go ahead and simplify the top. What could we pull out on top? The 1 and then x squared. Are there any groups of that? Just one group, because this is x times x and it's a square root. So this just becomes x over the square root of 5y. How do I get rid of that radical in the denominator? Times it on top and bottom. So this just becomes x square root of 5y over 5y. And this will not simplify further. okay? Because the x over 5y, that cannot be simplified. And then square root of 5y, there's no other square root on bottom that I could even try to simplify with because I got rid of it. So just leave it like that. Questions on that one? All right, go ahead and try 3. It's pretty easy. And then try 4. So just to rewrite these, just because I don't like the way they're written. This is 3, and then 4 is 12 cube root of 4 over cube root of 6x. All right, the first one. 1 over the 4th root of 7. What's the first thing that you did? Multiplied. So just looking at it, it looks like it's pretty simplified, right? But what's wrong with it? The radical on the bottom. I can't have that, okay? So that's what I need to multiply by. It's just 4th root of 7. When I do that, 1 times the 4th root of 7 is just the 4th root of 7. And then the 4th root of 7 times the 4th root of 7 is just 7. Can that be simplified any further? No, that's it. So those symbols just canceled out. Okay. Next up, we've got 12 cube root of 4 over 6x under a cubed root. My indexes are the same, so I'm good so far. 12 over 1, because I have an invisible 1 here. What's 12 over 1? This 12, right? So we'll keep that 12 on the top. 4 over 6x. Can 4 over 6 be simplified? Yeah. Both of them have a 2, so 2 over 3. And then I need to leave that x on bottom, right, because it's positive. Now what? What do we think? Yep, multiply by cubed root of 3x over cubed root of 3x. When we do that, 12 times 1 is just 12. Cubed root of 2 times cubed root of 3x, we just multiply what's underneath, so 2 times 3x, 6x. And then cubed root of 3x times cubed root of 3x, just 3x. Good deal. Anything else that can be simplified here? So I can't simplify what's inside this with what's not in a radical, right? Because I don't have a radical on the bottom. But what about this 12 over 3x? Can that be simplified? Yeah, what's 12 over 3? 12 divided by 3 is 4. So I can leave that 4 up here with the radical. And in the denominator, I still just have that x, right? So I'll leave that down there. Questions on that? Okay, let's keep going. So handling multiple values in the denominator. We use what is called the conjugate. Conjugate. Kind of a weird word. But this is how we rationalize the denominator if there's multiple values in there. So if it's not just one root, but it's got more than that going on, like that first one that we see, it's got a 1 minus the square root of 5. Okay, that's when we use the conjugate. So examples of conjugate. For instance, if my denominator, let's say I had 1 over, we'll do 4 minus the square root of 3. The conjugate of that would be 4 plus the square root of 3. Okay, the only thing you change on a conjugate is the sign that's in the middle. So if it is a subtraction sign, you change it to addition. If it is addition, you change it to subtraction. Okay, so same thing, another example. If my conjugate was square root of 6 plus 2, what would be the conjugate? Square root of 6 minus 2. So the only thing you change is the sign in between them. Okay, so given the following examples, it wants us to simplify by using that conjugate. So we've got 3 plus square root of 5 over 1 minus square root of 5. What is the conjugate for this one? So just the denominator. 1 plus the square root of 5. That was a really good point though, Timmy. Don't ever try to use the conjugate of the numerator. Okay? Please, please, please know that that is just, it only works for the denominator, not the numerator. Where's my eraser? Okay, there we go. So we're going to multiply by 1 plus square root of 5 over 1 plus square root of 5. Get in the habit of always using parentheses on these. Because to multiply values like this, we have to, what's it called? Oil. Yep. Okay. What'd you say? Yeah, you got it. Okay, so the first one, or the top, I guess. 3 times 1. 3. 3 times square root of 5.
3 square root of 5.
Good. And then we've got square root of 5 times 1.
Square root of 5.
Yep, just square root of 5. And then square root of 5 times square root of 5.
Square root of 25.
Good. Okay, now on the bottom, 1 times 1.
1.
1 times square root of 5.
Square root of 5.
Negative square root of 5 times 1.
Negative square root of 5.
And then negative square root of 5 times positive square root of 5.
Negative square root of 25.
Perfection. Okay, with me so far on how we FOILed out top, we FOILed out the bottom. Now we're just going to simplify, okay? We're actually, well, I guess we'll start with the top. So 3 plus 3 square roots of 5 plus 1 square root of 5 plus square root of 25. Do any of those roots simplify? Let's do that first. The 25 becomes 5 and 5, which is just one group of 5. So this just becomes a 5. Now let's do our like terms. So 3 plus 5, 8, and then 3 square roots of 5 plus 1 square root of 5. Just 4 square roots of 5. We know when we're adding, we're just adding those coefficients, right? And we can only add things that have the same radicand and index. Okay? Now let's go to the bottom. We already said that this broke down to 5, right? So this would just be a negative 5. What do I notice about the middle of that denominator? Yeah, so I have square root of 5 minus square root of 5. Don't those just cancel out?
Yeah.
Yeah. So basically my denominator is just 1 minus 5, which is negative 4. Okay, here's what you need to know. Just like whenever we multiplied by the radical in the denominator when it was just one thing, and it got rid of that symbol, because that's what we were trying to do. Do you see how all of the roots canceled out in the denominator here? How I don't have any roots? So what you're going to find out is that on the denominator, every single time, the middle cancels out on these. Every single time, the middle terms, the middle two terms, are going to cancel out. So really, when you just do, and again, this only applies for the denominator, but when you multiply, really the only thing I had to do for the denominator was I just needed to do 1 times 1 and negative square root of 5 times square root of 5. So just multiplying the outside terms. Does that make sense? because I knew the middle ones were going to cancel out. They're not going to cancel out on the top, okay, but they will cancel out on the bottom. Questions on that? Okay, let's real quick just look at our answer here. If you leave it like this is right. This is the right answer. However, what we could see here is that I've got my three terms. I've got 8, 4 square roots of 5, and negative 4. Do all of those have a number in common? 4. So if I see it, which I do see it now, I can go ahead and divide by 4, okay, or even by negative 4 to get rid of that negative on the bottom. And then that's going to simplify this further. So 8 divided by negative 4 would be negative 2. 4 divided by 4 would just be a negative 1 square root of 5. And then negative 4 divided by negative 4 is obviously just 1, so I don't even have to write that. So this would be the answer. However, if that confuses you, we'll save that for another day, okay? What our main focus today is just getting to this point, okay? So if you get there, I'm proud of you, okay? That means you learned what you were supposed to learn today. This was something that we should have learned in Algebra 1, okay? Don't know if we got that far, but that is something we will learn. We'll get to it, but I don't want to information overload you today. So if you're getting just to this point right here, that's our goal, okay?
Why couldn't you make it negative 3 to square root of 5?
Because these are not like terms here. Because this doesn't have a radical. Remember when we were adding and subtracting?
Why can't you make it negative 3? Because those are negative 2 and negative 4.
Because this is a negative 1 square root of 5.
Oh, okay.
See, and those aren't like terms. Good question though. Yep. And if you want to write the 1 out front, so like if just writing square root of 5, if it makes more sense to you to write the 1, that's okay. Okay? I just want you to do what makes sense for you and what's easiest for you. Okay, questions on that? That was a good question, Tate. All right, let's keep going. We're getting close to being done here. Number 2, what is our conjugate? 2 plus square root of 3 over 2 plus square root of 3. Simplifying the top on this one's going to work out pretty easy because we're actually just distributing instead of foiling, right? So what's 5 times 2? 10 plus 5 times square root of 3. Perfection. On the bottom, we know that our middle two terms are going to cancel out, so I'm just going to worry about the outsides and the insides. 2 times 2? Negative square root of 3 times positive square root of 3. Negative square root of 9. And that becomes just a negative 3, right? You with me? So what you're saying here is 10 plus 5 square roots of 3 over 4 minus 3. What is 4 minus 3? 1. So this is just 10 plus 5 square roots of 3 over 1. But I don't have to write the over 1. Questions on number 2? No? Okay. Go ahead and try number 3. All right, what's the conjugate on this one?
B plus, that's not a B?
No, it's not a v. It's a square root.
Why would it do that?
I don't know. It should be a square root. So square root of 3 plus square root of 7? Okay. So there's a hint. Use parentheses, that's another hint. Together. So we'll start with the top. 2 times square root of 3.
2 square root of 3.
Okay. 2 times square root of 7. Negative 21, or sorry, square root of negative 20, negative square root of 21. can't talk today, times square root of 3. Yep, negative square root of 63. And then we've got negative square root of 21 times square root of 7. Of what? 147. Okay. Now for the denominator, this is the easy part. Square root of 3 times square root of 3. Square root of 9, which is going to be just a 3. I could just know that those cancel out because it's the same radicand, right? And then negative square root of 7 times positive square root of 7.
Negative 7.
Yep, negative 7. So if you put negative square root of 49, you should have still been able to simplify 49 down to 7. Square root of 49. Okay. Now let's just look here at the top. Do I have anything that will break down? The 63, what's that going to break down to? 27, is that what you said? 9 and 7, okay, good. 9 breaks down to 3 and 3. Groups of 2 is what I'm looking for, right? So this becomes just negative 3 square root of 7. You with me? So we'll just cross this out because we just simplified it. Now 147, what can that break down to? It's one you probably have to use a calculator for. 49 and 3. Good. 49 breaks down to 7 and 7. So this becomes a negative 7 square root of 3, right? Because we had a group of 7, a 3 left over, and a negative sign right here. So on top, 2 square roots of 3 minus 7 square roots of 3. Yep, minus 5 square roots of 3. And then 2 square roots of 7 minus 3 square roots of 7. Minus the square root of 7. Okay. 3 minus 7. Negative 5. That is as simple as this one will go. The only thing you could do on this one is I noticed that all of these are what? Negatives. So I could just multiply by negative 1 on top, negative 1 on bottom, and it would make the whole thing positive. Okay? So if you want to do that, so times by negative 1 times by negative 1, it would just be 5 square roots of 3 plus square root of 7 over 5. But if you left it this way, not counting it wrong. Okay? Just happy that you made it that far, because that is the goal for today. Okay, questions so far? All right, number 4. Am I using a conjugate on this one? No, why not? Yeah, the denominator just has that one variable in it, that one term. Okay, so there's no point in using a conjugate. I just need to multiply the whole thing by square root of 2. So go ahead and do that. Try that one. You still have to know that this is still in parentheses though, because that square root of 2 is being multiplied by that whole thing. Okay, so make sure you see that that's 2 terms. Okay, so on top, what was the first thing that you did? Yeah, multiply. So basically this is being distributed, right? Because it's being multiplied by both. So 3 square roots of 5 times the square root of 2. Good. Negative 6 times the square root of 2. And then on bottom, just a 2. Raise your hand if you got that far. Good deal. Hopefully if you did not, you see what you did wrong. Can any of this be simplified? Square root of 10, will that simplify? It breaks down to 5 and 2, but that's not a group of 2, right? So no. Do 3, 6, and 2 have anything in common? Does 3 have 2 in common though? No. So I think this one's good. I think that's as far as it's going to go. Make sure you do check though. Check and see. All right. Example 5. Getting close to being done for the day. Try this one. All right. Conjugate on this one. What are we multiplying by? Perfection. Square root of u plus the square root of 6 on top and bottom. On top, square root of 3 times square root of u. Good. Square root of 3 times square root of 6. Good. Square root of u, hold on bottom. Square root of u times square root of u. Negative square root of 6 times square root of 6. Good. On top, will that simplify any further? Yeah? Which one? Square root of 18, what does it become? 9 and 2, 3 and 3, so it becomes 3 square roots of 2. So we've got square root of 3u plus 3 square roots of 2 over u minus 6. Okay. Looks pretty good to me. Think we're done? I think so. You think we're done for the day?
Yes.
Feeling good about this? Yeah? Good deal. So that's it for today's notes.